Right, we are back with some quick math. We're doing Euclidean geometry. We've covered theorem 1. We've done the proof. So now we're going to do an example or two examples where we use the theorem 1. Right. So for the pure math learners, you need to be able to do the proof of theorem 1. You don't need to be able to do the converse, right? You do need to be able to do the proof. I am going to say share this video with those who do technical math as well, because for the technical math 11 and 12, you don't need to do the proofs, but you do need to be able to use the theorems, which we're going to do in this video, and any other example videos. So technical math learners, you can skip over the proofs, although it is good to know, so see it. You don't need to be able to prove it yourself. Pure math learners, there's 4 of them that you do need to be able to prove yourself, and I will indicate those as we go through them. Right, so let's read this question. It tells us there's a circle center at O. So they must tell us the center is O. If they don't tell us that's the center, we can't really apply the theorems that include the center. There are some theorems that don't include the center. The ones that do include the center, they must tell us that that's the center, right? They tell us the radius is 10 units. Now, it's important, especially for this question, that you understand that the radius, or rather by definition, the radius is from center to circumference. From center to circumference. So that's a radius, that's a radius, that's a radius. Anywhere from center to circumference is your radius. Okay, why that is important? Because they drew the radius over here. We don't need it over there. In fact, we need the radius somewhere over here to complete our triangle. So we know this is also 10. Okay, that's also 10 units. The fact that they put it over here, well, maybe they try to trick you. Okay, so that's still the radius. They tell us that OQ, right, this is OQ, is perpendicular to PR. There's our theorem, right? So our theorem 1 tells us line from center perpendicular to chord bisects the chord, right? So we know that this length, whatever that is the same as this length, whatever that is. Okay, so we do need to write a statement to prove that. So let's maybe write that statement. So we are going to say that PQ, we will say PQ is equal to QR. Right, our reason how we know this is line from center. I am sitting outside, sorry for the noise in the background. Line from center and we'll say perpendicular to chord. Right, I did send you a doc that has all the valid reasons. Make sure you go through that. If you don't have it, Google it, you'll find it somewhere. But you must have the Euclidean reasons perfect. Okay, line from center perpendicular to chord. So now we know those two are equal. They do tell us, if we go back to the question over here, we didn't complete reading it, and PR, right, is 8 units. That's not shown on our picture. For the majority of the time, the information will be shown on the picture, but this one wasn't. So it is very important that we read the question. So PR, this is this complete length. That is 8 units. All right. So we said that these are equal to each other. Therefore, so we'll say, we can say therefore PQ equals 4 units. Okay, all right, great. So we use our theorem. We know that that is for the smaller part here is 4. Right, so now I'm sure we've seen it, but we have a right angle triangle. We are given 2 sides. We need to find X, the missing side there. Obviously, we'll go with Pythagoras. So we are using Pythagoras and we are finding one of the short sides. And because we're finding a short side, we know there's going to be a minus in between our values. So we'll say X is equal to, and we'll go straight to the square root of 10 squared. That's the hypotenuse. The hypotenuse gets squared, and then you subtract one of the other short side squares, so it's going to be 4 squared. Right, so let's do the math here. Square root 100, 10 squared is going to be 100, minus 4 squared is 16. So 100 minus 16 is square root of 84, and you can put that in your calculator and we'll say units. Right, so that is the value of X. That is not the simple set. You go ahead and find the simple set. I don't have my calculator. So that's our first one. I think let's leave the second one for the next video. Right.